5A, solving exponential and log equations. Obviously, that is our objective as well. So there's a couple of different strategies for solving exponential and logs, and it really depends on the type of question that you're given. So one strategy is you could rewrite it so that you can use the one-to-one properties. If two exponentials have the same base, then the exponents are equal. If two logs have the same base, then what you're taking the log of is equal. And we'll see an example for sure of the exponential one. That's the one I tend to use more often because exponentials make more sense to me when I'm thinking about the problem. Another would be to rewrite so you can use the property where a log and an exponential cancel each other out. Either way, either log base a of a to the x or a to the log base a of x. All right, so our first example, we've got 2 to the x power equals 32. So the first thing that I think about when I see an exponential is, can I get my answer rewritten with the same base? 2 can only be rewritten as base 2, but 32 is 2 to the 5th power. So x equals 5. We can just cancel our bases. Our second example, the first thing that I would do is use the property of logs where I would condense these to a single log. So the subtraction condenses to division. And then I would do 10 to the 0 power equals x over 4. 10 to the 0 power is 1. So to solve for x, I would multiply both sides by 4. This next example, 1/3 to the x power, I would use the first strategy where I would rewrite 9 as base 1/3, or you could rewrite 1/3 as 3 to the -1 power and use properties of exponents that way, because it might be easier to see 9 as 3 squared versus 1/3 to the -2 power. That would be the other option. And I'll show you what that looks like as well, if that makes more sense to you. So on the left-hand side, we have our power of a power rule, so we multiply our exponents. So negative x equals 2, so x equals -2. The other way to look at it is 1/3 to the x power, and knowing that 9 is the reciprocal of 1/3 squared. So you could rewrite this as 3 squared gives you 9, the negative flips it. And then obviously the x would equal -2. So on B, 8 cannot be rewritten as base 4, but 4 and 8 can both be rewritten as base 2. So 4 is 2 squared, 8 is 2 cubed. Again, using our power of a power rule, I get 2 to the 2x equals 2 cubed. So setting the exponents equal to each other, I get x equals 3/2. Similar on this one, 8 can be rewritten as base 2. So I would rewrite 8 as 2 cubed. Using our power of a power rule, I would multiply those exponents. And then once we have the same base, we can set the exponents equal to each other and solve from there. So subtract x from both sides and divide by 2. All right, this next one, I would use my curly law and rewrite it in exponential form. 7 to the -1 power equals x. So 7 to the -1 is 1/7. These two examples were on your homework. I think it was 7-4A assignment. And what I noticed was a lot of people evaluated those using the change of base formula because I hadn't shown you yet how to do this. So these are two examples of what might show up on a no calculator portion of a test or a quiz. So the first thing we're going to do is use our curly law. At least I would. Exponentials make more sense to me when I'm going through solving the equation. You can solve this in log form, but my guess is since logs are new to you, exponential might be an easier way for you to think about it as well. And then what I notice is that 9 and 27 are both base 3, so I would rewrite 9 as 3 squared And I would rewrite 27 is 3 cubed, but the negative would flip it, so that would be 3 to the negative 3 power. Using the power of a power rule, and then dropping the bases once they're equal to each other. X is negative 3 halves. Similarly on this one, I would rewrite this in exponential form. 8 to the x power equals 32. 8 and 32 can both be rewritten as base 2. 8 is 2 cubed. 32 is 2 to the 5th. So we have 2 to the 3x power equals 2 to the 5th. Dropping the bases and solving for x, we get 5/3. All right, so we need to slide this a little bit. All right, so now what we have on these is 4 to what power gives us 72. I'm not seeing any base that 4 and 72 have in common. So I would rewrite this in log form. So this becomes log base 4 of 72 equals x. So the base of the exponential, remember, becomes the base of your log, and then the exponent becomes the answer. So this becomes a change of base formula. So I would rewrite this as a common log. Remember, what you're taking the log of is higher, so that stays above the base, which is lower, and that goes in the denominator. So then we would evaluate this on our calculator, and approximately equal to 3.085. Similarly on B, 200 cannot be rewritten as base 5. So I would do log base 5 of 200, and the exponent becomes the answer. Using change of base, log of 200 over log of 5. And when we evaluate that, we get approximately 3.292. So adding 2 to both sides, we get about 5.292 equals x. Last slide. So on these, this first one, I would use the curly law to rewrite this as 3 squared equals x minus 5. So we get 9 equals x minus 5. Adding 5 to both sides, we get 14. On B, I would condense this first to a single log. So we get 45x divided by 3, because our subtracting logs, when we condense it, it turns into division. And then I would use the curly law. We've got the common law, base 10 to the first power equals 45x over 3, and I would simplify that to 15x. And 10 to the first power is 10, so when I divide both sides by 15 and simplify, dividing 10 and 15 by 5, I would get 2/3 equals x.